Vehicle Weigh in Motion (WIM) data is an integral part of traffic data. It offers critical information related to the design, operations, and management of pavement, bridge, freight, and safety of our transportation system. FHWA has prepared a three-part set of pocket guides providing detailed technical knowledge and best practices on how WIM activities can be carried out effectively and efficiently. Part 1 of the pocket guide deals with WIM technology selection, data acquisition requirements, and procurement, and its target audience is WIM program managers and WIM program-level decision-makers. Part 2 deals with WIM site selection, design, and installation and is targeted to traffic engineers, senior WIM specialists, and WIM site-level decision-makers. WIM maintenance and calibration is the subject of Part 3 and is targeted to technicians involved in routine WIM maintenance and calibration activities. These pocket guides can be found on the FHWA's Office of Highway Policy Information website. The companion videos provide WIM professionals a practical sense with installation of WIM sensors. This instructional video will show you how to install the bending plate weigh in motion sensor. The procedures shown in this video are recommended best practices and are not meant to circumvent the manufacturer's installation specifications. Several installation topics will be covered in this video. We'll show you how to lay out the sensor, explain proper saw cut and excavation procedures, show how to epoxy the frame, clean up the frame to maintain road smoothness, and how to install the WIM sensor. A list of installation steps and a quality assurance checklist will be provided for each topic. In preparation, here is a list of the tools that are needed. This list is not all-inclusive. The manufacturer's installation guide and other project documentation should be referenced for more detailed information and additional preparation requirements. The materials list may also be available in the manufacturer's installation manual, which may contain a list of additional materials that are needed for installation beyond what is provided in this video. It is imperative that all construction crew members wear proper personal protection devices and are briefed on the various hazards associated with working near traffic and in industrial environments. The use of a traffic spotter while working near active traffic lanes is highly recommended. Let's start the installation process with sensor layout. First, we need to determine the correct location for the frames and loop sensors. To begin, create a reference line perpendicular to the outside pavement marking. From the reference line, measure and paint the locations of the frames and loop sensors on the pavement. A line perpendicular to the lane or pavement edge serves as a reference line for the sensor layout. Use the properties of similar right triangles to assure that the line is perpendicular. At the desirable sensor location, make a mark on the inside edge of outer pavement marking. From the original mark, walk straight into the travel lane and place additional marks at 3 feet, 6 feet, and 9 feet from the original mark. Next, walk along the pavement edge and place additional marks along the inside edge of the lane, marking at 4 feet, 8 feet, and 12 feet from the original mark. Extend the tape from the 4-foot mark toward the 3-foot mark. Measure to 5 feet and draw the arc that intersects the 3-foot mark. Extend the tape from the 8-foot mark toward the 6-foot mark. Measure to 10 feet and draw an arc that intersects the 6-foot mark. Extend the tape from the 12-foot mark toward the 9-foot mark. Measure to 15 feet and draw an arc that intersects the 12-foot mark. Once all the marks are drawn, there will be 3 sets of X's in the lane. Starting at the original mark, extend a string across the travel lane, intersecting each X. This is a perpendicular reference line. Spray paint over the string or rope to create the perpendicular guideline to follow during sensor slot cutting. Remember these 3 tips for sensor layout quality assurance. First, ensure the layout of the frames and loop sensors are perpendicular to the pavement markings by verifying the proper use of the right triangle method when creating the reference line. Ensure that ambiguous paint marks are crossed out or blacked out to avoid confusion. All sensor pavement cut measurements should match what is documented in the contract and must follow manufacturer installation guidelines. The second topic is saw cutting and includes 3 steps. First, align the saw blade with the painted markings. Then, slowly lower the blade into the pavement to the specified depths. Finally, cut along the pavement markings from the starting point to the ending point. Do not overcut the frame saw cuts. The saw operator lowers the blade into the pavement at the specified depths. If water is being used, keep the water running to keep the dust minimized and the blade cool during operation. Otherwise, ensure the operator is wearing a dust mask and use compressed air to blow the dust away from the operator. The operator will cut as straight as possible along the previously made pavement markings. The corners of the loop sensors are overcut to ensure the blade has met the minimum depth where the loop wire will be placed. Use a depth gauge to make sure that all cuts are at the proper depth. To assure proper sensor saw cutting, be sure you can answer yes to these 4 questions. Is the blade the correct size? Are all the saw cuts at the proper depths? Are the saw cuts straight and along layout painted markings? Are overcuts made at the corners of the loops? Frame recess and loop slot preparation is the 3rd topic. For this step, excavate the material from the frame recess using a jackhammer with spade bits. Drill anchor holes to the proper depth using a rock drill. Blow excessive debris out of the slot. Clean the frame recess, anchor holes, and loop slots with high-pressure water and/or air and vacuum. If water is used, dry the recess, holes, and slots with clean pressurized air until all moisture is gone. Or, scrape or brush the sides of the recess and the holes to remove all excess debris and then blow everything clear. The crew will use a jackhammer with spade bits to remove the pavement from the interior of the frame recess. When complete, the excavated area will allow the installation of the frame with a little bit of extra room beneath. Some installations may include drain channels that will be excavated lower than the load-bearing areas. The anchor holes will be drilled with a rock drill with a 1 inch to 1.5 inch bit at a 90 to 45 degree angle to the required depth depending on the type of frame. All loose pavement and debris is removed from the frame recess. Loop slots in the frame recess and anchor holes are blown out with high-pressure air. The crew may blow the frame recess, anchor holes, and loop slots with clean, high-pressure air or rinse it with a pressure washer, moving side to side and away from traffic until all debris and standing water has vacated the slot. Whether using water or not, the recessed area, including the anchor holes, is blown with clean pressurized air until all standing water and other debris is gone. For quality assurance, ensure that the frame recess and anchor holes have been excavated or drilled to the proper depths. Ensure that the frame recess, anchor holes, and loop slots are clean and dry and that no standing water remains. Check the entire frame recess, each anchor hole and loop slot to make sure that they are the proper size and depth over the entire length and width. The next topic is frame preparation and conduit installation. For this step, the drain and lead-in conduits are installed. The frame leveling aids are installed and the frame is dry fitted into the recess. Concrete is then mixed and applied to the inside of the frame to create the epoxy dam. Depending on the type of frame being installed, the frame may or may not be removed. The conduits are then plugged to prevent debris or epoxy intrusion. The metal drain and electrical conduits will be installed in the home run slots, with the drain conduit at least 1/2 inch lower than the electrical conduit. 1 inch PVC will be installed in the loop home run slot where it enters the frame recess. The leveling aids, which may be prefabricated, will be installed on the frame. The frame is dry fitted into the recess to ensure adequate clearance for the conduit and to adjust the leveling aids to set the frame at the right height. Once the frame is set to the proper height, concrete is mixed and packed in around the inside of the frame and around the conduits to create a dam that will prevent the epoxy from entering the electrical drain channel that runs down the middle of the frame recess. While the concrete is still wet, the frame may be removed and set beside the recess, or it may remain in place and additional anchors will be installed. Allow the concrete to harden just enough to have enough structural integrity that it will hold back the epoxy when it is poured. Place duct tape over the ends of the conduits to prevent epoxy or dirt from entering them. To ensure proper frame preparation and electrical drain conduit installation, follow this quality assurance checklist. Metal, electrical, and drain conduit is properly installed in each frame exit channel. PVC is installed for each loop entry into the frame recess. The frame leveling aids are properly installed. The frame fits into the recess properly. The leveling aids are adjusted so the frame is set to no higher than 1/16 of an inch below the pavement surface at the highest point. The concrete is mixed according to the manufacturer's instructions. The epoxy dams are installed. The drain and electrical conduit ends are covered. The next topic is epoxy mixing and pouring. It includes 6 steps. First, pre-mix the epoxy, combining the sand with the resin. Next, add the hardener and mix per manufacturer instructions. Within the prescribed time, pour the epoxy first into the anchor holes to ensure that they are full, then around the frame so that it pours down around the sides of the frame. If the frame has not yet been placed, fill the recess area up to the top of the concrete dam. Use a trowel to sweep the epoxy up on the outside edges. Use a wire brush to scratch the epoxy into the outside vertical edges. Then set the frame into the recess and apply pressure to push it down into the epoxy. The epoxy will be mixed according to the manufacturer's instructions. Once the epoxy has been properly mixed, it will be poured quickly into each of the anchor holes until they are filled. Then, the epoxy will be poured into the frame-bearing area on the outside of the concrete dam until it reaches the indentation left by the frame during the dry fit. If the type of frame being used is placed after the epoxy will be swept up on both sides of the slot using a trowel, then scrubbed into the vertical sides of the frame recess before the frame is placed. Be sure you can answer yes to these questions for epoxy mixing and pouring quality assurance. Was the epoxy mixed according to the manufacturer's instructions? Were the anchor holes filled with epoxy? Were the frame-bearing areas filled with epoxy up to the top of the concrete dam? Was the epoxy swept up on both sides of the recess? Was the epoxy scrubbed into the vertical sides of the recess using a wire brush? Topic 6 is frame installation. This topic is discussed for installations where the frame was removed after it was pre-fitted into the recess. This topic involves 3 steps: installing the frame into the recess, hammering the anchor bolts into the anchor holes, and cleaning off the excess epoxy. If the frame was pulled during the epoxy pouring setup, the crew members will replace the frame using the indentations on the concrete dam as a reference, push the frame down into the epoxy, and place weight on the frame to hold it in place. The next step is to install the anchors into each of the anchor holes until the anchor heads are completely flush within the anchor head recesses in the frame. After the anchors are installed, weights will be placed on the leveling aids and frames to keep the frame from floating up. Once the position of the frame is set, excess epoxy will be scraped from the frame and the roadway. Be sure you can answer yes to these questions for frame installation. Are the leveling aids in contact with the pavement surface? Are the anchor bolts completely installed? Has all excess epoxy been scraped from the frame and the roadway? Topic 7 is epoxy curing and frame cleanup. Here are the steps. After the epoxy is hardened, remove the weights and leveling aids from the frames. Use a grinder to remove any remaining epoxy from the frame and roadway. Clean the frame and paint any bare metal areas with rust-proof paint. After the epoxy is cured, the weights and leveling aids will be removed from the frame. Any excess epoxy on the frame and the roadway will be ground down. The frame will be cleaned off with pressurized air. Any exposed metal areas will be painted with rust-proof paint. Here is a list of quality assurance tips for epoxy curing and frame cleanup. The epoxy has fully cured. All excess epoxy has been removed from the frame and roadway. The frame was properly cleaned. All bare metal areas were painted with rust-proof paint. Topic 8 is insert installation. Some vendors require the use of a conversion insert to accommodate the use of bending plates with the frame. If this is required, there are several important steps associated with this process. First, carefully place the insert into the frame. Next, mark the anchor holes and pre-drill the holes. Use a hammer drill to drill each of the anchor holes. Install the anchors onto the insert and replace the insert in the frame. Next, epoxy the anchors into place. Finally, place the shims onto the insert. The insert is carefully removed from the box or crate and placed inside the frame. The anchor holes are then marked with spray paint and pre-drilled. The insert is then removed so the anchor holes can be drilled out and the anchors can be mounted onto the insert. The insert is then placed into the frame so that each of the anchors goes down into the drilled holes. The anchors are then epoxied. Lastly, the shims are placed in the insert. Be sure you can answer yes to these questions for insert installation quality assurance. Were the insert anchor holes drilled to the proper depth? Were the anchors securely fastened to the insert? Do the anchors fit properly into the anchor holes? Were the anchor holes filled with epoxy? Were the shims placed on the insert? Topic 9 is bending plate installation. There are several important steps associated with this process. First, carefully remove the sensor from the box and place it on pieces of wood near the frame. Uncoil the sensor lead and run the lead through the small conduit or hole in the frame and through the sensor conduit to the pull box. Lift the sensor and carefully lower it into the frame. Use a 4-inch straight edge or level to determine if any shims are needed to make the top of the bending plate flush with the pavement surface and install the shims. Install the securing rails and use a torque wrench to tighten the nuts onto the bolts. Check the top of the bending plate with a straight edge to make sure it's flush with the pavement surface. If it is not, measure the gap, remove the securing rails and weigh pad, and add or remove rail shims as appropriate. Reinstall the securing rails and torque the retaining bolts down. Caulk the bolt holes and around the edges of the bending plate where it meets the frame. The bending plate is carefully removed from the box or crate and placed upside down on pieces of wood next to the frame. The lead-in exit is aligned with the lead-in conduit welded to the frame. The lead-in cable is carefully uncoiled, run through the frame conduit, electrical conduit, and into the roadside pull box. After all the shims have been placed, the bending plate will be lifted into place, turned over, and lowered into the frame. The retaining rail shims are then installed, followed by the retaining rails. After the rails are secured using the associated hardware, the nuts are torqued down to within specification, and the height of the bending plate is checked with a straight edge. If the bending plate is not flush with the pavement, the retaining hardware is removed, the frame is reshimmed, and the bending plate is reinstalled and rechecked. Once the bending plate is flush with the pavement surface, caulk is applied to the edges of the frame and to the securing hardware holes. Be sure you can answer yes to these questions for bending plate installation quality assurance. Were the lead-in cables carefully uncoiled and pulled through the conduits? Were the retaining nuts properly torqued down to manufacturer specification? Is the bending plate installed flush with the pavement surface? Was caulk applied to the frame edges and the retaining bolt holes? The information presented in this video will ensure that the sensor is properly installed by demonstrating each of the critical steps involved and providing several quality assurance checks for each step. The proper installation of the bending plate sensor will extend the service life of the sensor and ensure a higher level of WIM data quality for the life of the WIM system.